Hi, this is Jason Baker, and welcome back to our lecture on container orchestration. So, what is orchestration? What do we mean by that term? Well, orchestration is basically a set of processes that we can use to control the life cycle of infrastructure resources. You can kind of think of it as like a set of CRUD operations on compute storage and network infrastructure. In other words, orchestration allows you to create, update, and delete infrastructure resources. And we use some sort of tool or platform to perform orchestration operations. And you've already used these sorts of tools throughout the course. For example, when you're using the AWS console, or if you're exercising the AWS API, you can use those tools to essentially sort of automate the creation and termination of infrastructure resources running in AWS. You can use EC2 auto scaling groups to automatically create new EC2 instances based upon some sort of trigger. You've used CloudFormation and you've defined CloudFormation templates. When you launch a new stack using a CloudFormation template, then AWS will automatically create all of the resources defined in that template. And you can think of the process that AWS is using as an orchestration process. So when AWS is creating all those resources, we say that AWS is orchestrating our infrastructure. We've used tools like Elastic Beanstalk, and we've used Ansible. These can also be thought of as sort of orchestration tools. So there's a wide variety of different ways that we can automate the building of our infrastructure. And as I've said, we've used many of these different tools throughout the course. Well, what I want to focus on in this lecture is specifically orchestrating containers. And you already know that containers are like super processes. They're not like, a virtual machine and not like a physical server. So orchestrating containers is a little bit different than maybe orchestrating some of the other infrastructure components that we've worked with in this course. Now, with a container, you can run multiple containers on a single computing instance. And if you're working with a modern application platform, you'll find that modern platforms will dynamically create and destroy containers on demand. So a platform might scale up the number of containers to handle an increasing number of jobs in a queue, or to support greater demand on the application. So our container orchestration platform needs to be able to do a couple different things in order to sort of manage containers in our environment. The orchestration platform needs to be able to provide some sort of high availability if a container or the host that the container is running on fails. It needs to be able to distribute requests across a set of containers, because oftentimes, you're not just running one container for a given service. You've got multiple containers because you want to provide for high availability. The container platform needs to be able to deploy application updates. You might have an application platform that's comprised of dozens of different sorts of containers, each one of which has its own image. And you'll be updating the code in those images over time, and you need a way to be able to update those images and apply updates to your containers. And then finally, the orchestration platform needs to provide some sort of service discovery mechanism so that services that are running in containers can find other services that are running in the same environment. So what does this look like in the real world? What is a container orchestration platform allowing you to do? Well, basically allows you to define containers, and then the orchestration platform is going to figure out the best location to run those containers. It's going to figure out the best host to run those containers on. So when we've been working with containers so far in this course, we've been manually launching containers and creating containers, and we've been running those on one particular host. But that's not very resilient, right? If you want resiliency, you know that you need to be able to run services across multiple hosts, across multiple EC2 instances, and also preferably run those instances in different availability zones, so that if you lose an availability zone or lose an instance, then your service is still up and running because there's there's multiple containers supporting each service, and those containers are distributed across a set of services running in different geographic locations. So the container orchestration platform, its job is to figure out where to run containers. Where's the optimal place to run containers? As a developer, then you're just defining how the container is built. You're building the container images and you provide it to the orchestration platform, and then it goes off and figures out where to run those containers. The orchestration platform then will also monitor the health and state of the containers, and then it will automatically handle any sort of topology change that takes place. So if your containers are running on multiple Docker hosts, and if you lose one of those Docker hosts, then the orchestration platform will sense that that host has failed and may automatically restart those containers on a different host in the environment if there's capacity available. So the container orchestration platform is trying to maintain some sort of desired state. You've described to it what containers you want to run, how many of those containers you want to run, and the orchestration platform is going to continuously monitor the infrastructure environment and try to keep all of your containers up and running. And then finally, the orchestration platform is going to help you wire up your containers so that the services running in those containers can communicate with one another. That orchestration platform is going to automatically set up the networking layer for you to enable that. And of course, it may need to dynamically change network configuration settings as topology changes occur within the environment, or as new services are introduced into the environment. So let's look at a couple different container orchestration platforms that are available in the marketplace. And then we're going to do a deep dive on one of these specific platforms, the Docker Swarm platform. So the first platform I'll talk about is the AWS Elastic Container Service, otherwise known as ECS. And ECS has been around for a couple years now, and it's a relatively popular solution. What ECS allows you to do is define containers and then deploy those containers on top of AWS managed infrastructure. And what AWS is actually doing is it's launching a set of managed EC2 instances. And these EC2 instances are essentially Docker hosts. You can then define your containers, and AWS will automatically deploy your containers into these managed hosts and take care of monitoring the health of the hosts and ensuring that your containers stay up and running. Another part of the ECS service is the AWS EC2 Container Registry, also known as ECR. And the ECR is basically a private Docker image repository. So if you recall, when you create Docker images, you generally want to store those images in some sort of centralized repository. There's the globally available Docker Hub service that you could use, or you can create your own private repository, and that's what the ECR service allows you to do. It's a Docker repository service managed by AWS, and into which you can publish your Docker images. And I use this particular service quite a bit. So that's ECS. The second service we'll take a look at briefly is a relatively new service called AWS Fargate. And this service was launched in late 2017. I haven't had a chance to really use this service much yet, but it's an interesting service because essentially what AWS is allowing you to do is to create containers and then deploy those containers as a fundamental compute primitive, just like an EC2 instance. So when you create an EC2 instance, you're specifying an AMI, and then Docker will launch, or AWS will launch a virtual machine that's running your image and all of your desired software, and of course an operating system. With AWS Fargate, you are providing a Docker image, and then AWS will launch that Docker image as a Docker container and then allow you to interact with that container kind of like it's just like an EC2 instance. So you can use it as sort of a fundamental building block for your application platform. And the Fargate instances, containers, they integrate with all the other AWS services like VPCs and the Elastic Load Balancing Service, of course, IAM, roles and policies, CloudWatch. You can use them with CloudFormation and so on. So what's interesting about Fargate is that it sort of fundamentally changes the way that we view containers because sort of up till now, we've treated containers as being like these very specialized super processes that are running on our hosts. In this case, AWS is taking care of the hosting, so you no longer care about the underlying host. You just create the container, and then you can launch it and deploy it and treat it like it's another server in your environment. So really interesting concept. And AWS Fargate in some ways eliminates the need to manage an underlying container orchestration platform. Okay, the next service we'll look at is AWS EKS, and this is also a relatively new service, launched in late 2017. And what AWS EKS allows you to do is to deploy your containers into a managed Kubernetes cluster, within AWS. So instead of creating your own Kubernetes cluster and running it on your own EC2 instances, you can essentially allow AWS to manage all that underlying infrastructure for you. So I mentioned Kubernetes, and Kubernetes is the next platform I wanted to talk about. Kubernetes is an open source container orchestration platform that was started by Google a number of years ago. The name Kubernetes is based on the Greek name, which means helmsman or pilot. So that's where the Kubernetes name came from. Sometimes the Kubernetes name is shortened to K8S. You'll see that three-character abbreviation, K8S, and that stands for Kubernetes. So Kubernetes is based on some of the key technology practices that Google uses to scale their own global platform. So they've taken a number of their technology practices and integrated them into the Kubernetes platform. And Kubernetes provides this abstraction layer that we can use to manage running containers and ultimately make our application deployments much easier. When you create a Kubernetes cluster, you take a number of servers, so EC2 instances, and you can deploy your containers across a set of instances. And within each cluster, there's a master instance, and then there are multiple nodes. And the master instance is responsible for managing the different resources and coordinating the orchestration activities within the cluster. In other words, the master instance is responsible for figuring out where to launch and where to schedule the creation of container resources within the cluster. And it also will monitor the health and state of those resources. Each computing node within the cluster runs something called a kubelet, which is basically a software agent. And that kubelet agent um, will communicate back with the master instance, and so that's how the master instance can coordinate and schedule the running of containers on the computing nodes within the cluster. And also, each of the computing nodes will run a container engine, such as Docker. And so the actual containers then will run on the computing instances. And all of the nodes, computing nodes, are communicating with the master using a Kubernetes API. And so that's what's used to coordinate and communicate how containers should run within Kubernetes. Now, we don't use Kubernetes in this class, but I should note that Kubernetes is now probably the most popular orchestration platform in the marketplace, and it's used by a number of large regional organizations. Uh, its future, however, I think is still sort of in question because cloud providers like AWS are starting to launch services like Fargate, which in some ways almost eliminate the need for an orchestration platform like Kubernetes. So this is a rapidly changing and evolving marketplace. So it'll be interesting to see how these sorts of solutions evolve in the future. Kubernetes, while it's the probably the most popular platform today, is also one of the most complex, and it's one of the reasons why I don't cover it too deeply in this course because I would probably need several lectures just to cover Kubernetes.